Problem 1. AC power from the wall has an RMS voltage of 110 volts. What is the largest potential difference between the hot plug and the neutral plug? Please pause the video and attempt this problem. So if we use how we defined RMS before, the RMS quantity is equal to the peak quantity divided by the square root of 2. This means we can rearrange the equation to say that the peak quantity is equal to the square root of 2 times the RMS quantity. So VRMS was 110 volts. So the square root of 2 times 110 volts, that gives us a peak voltage of 155.6 volts. Now, as I mentioned in the lecture, this is probably not actually true in the case of wall voltage, because wall voltage is very messy. Problem 2. When attached to wall current, which again has an RMS EMF of 110 volts, a device has 100 ohms of resistance and negative 75 ohms of reactance. What is the average power draw of this device? Please pause the video and attempt this problem. So first, let's find the impedance. We are given resistance and reactance, and we can use the formula that impedance is equal to the square root of resistance squared plus reactance squared. So this term, 100 squared plus 75 squared all square rooted, gives us 125 ohms of impedance. We can also find the phase angle of the impedance by finding the arctangent of reactance divided by resistance. And this gives us a phase angle of negative 37 degrees. Now let's use this information. The question is asking, what is the average power draw? We have the RMS voltage. We just calculated the impedance, and we know the phase angle, which means we can find the power factor. So we can go ahead and use this form of the power formula, plug in our values. ERMS is 110 volts, Z was 125 ohms, and this power factor, the cosine of theta, is 0.8. And yes, you still have a positive power factor even when theta is negative. Plug all these numbers in and you get an average power of 77.44 watts. Question 3. You use a digital multimeter to see that the voltage across the device is given by V of t is equal to 200 volts times the cosine of 300 per second t minus 20 degrees. And the current through the device is given by I of t is equal to 20 milliamps times the cosine of 300 per second t plus 20 degrees. What is the instantaneous power draw and what is the average power draw? Please pause the video and attempt the problem. So first, instantaneous power draw is given by P of t is equal to I of t times V of t. I of t is 20 milliamps. If we convert that to amperes, that's 0.02 amperes times this cosine function. V of t is 200 volts times this cosine function. So 20 milliamps times 200 volts is 4 watts, and we just multiply these cosines together. Now, if that looks messy, it is. There are some things you can do with sum of angle trig identities that might clean it up, but also in some ways makes it worse, so I haven't bothered. Now for the average power draw, one thing we could do is take this power function, integrate it over time. Because the angular frequency is 300 per second, we could integrate it from t equals 0 to t equals 2 pi over 300 seconds. But that would be unnecessary because we have this formula right here. P equals IRMS times VRMS times the power factor. So now we haven't been given IRMS or VRMS. We've been given the peaks, I naught and V naught. But we know that IRMS is I naught over the square root of 2, and VRMS is equal to V naught over the square root of 2. Even better, we don't actually have to divide by the square root of 2, because we have 2 square roots of 2 in the denominator. Multiplied together, that just becomes 2. So this 0.02 amps times 200 volts divided by the square root of 2 divided by the square root of 2, that's just, this is 2 watts. However, we still need to contend with the power factor. The power factor is equal to the cosine of 40 degrees. Why 40 degrees? Because voltage is at phase negative 20 degrees, current is at phase positive 20 degrees, which means there are 40 degrees of difference between those two. So that means that the phase of the impedance is 40 degrees, so cosine of 40 degrees gives us our power factor, which gives us an average power of 1.532 watts.